going to roll, we are going to slip, but not slip in concepts for sure. And I'm pretty sure most of you like bikes, cars, and anything that rolls, but definitely maybe not like this. I'm pretty sure nobody wants to roll like this. Or maybe you want to roll like this, like a cute little panda. How many of you want to roll like a cute little panda and just want to laze around whole day? All right. Anyway, so let's get going, guys, with me, Shreyas, your master teacher for physics at Vedantu, going live. And today we are going to roll, we are going to slip, and we are going to cover all the concepts which are essential for JEE, for all the competitive exams from rotational mechanics. This is session number 3 with me, Shreyas, your master teacher for physics and your anchor for this channel, JEE Enthuse. Welcome aboard. Hello, Instantaneous, Uncharted, Science, Priya, Satish, Ryan, Jumna. Welcome, Vemula. Welcome, Ryan. Welcome, Aarti. Hello, everyone. How is everyone? Hello, Nisar. Hello, Pranuti. Hello, Ankit. Welcome aboard. Hello, Shreya. I hope you guys are fabulous, and I know you guys are all excited for the session. Remember, in this flash series, we are going to cover all the concepts before your exams so that you are very well prepared for the first attempt when you're going to write in February. And I conducted a very special lecture on Saturday, and I know most of you are already there, but in case you have missed it, do visit the most important announcement for you guys because it is important for you. And remember, on this channel, we are going to make all the important announcements, all the necessary tricks, all the tips that are needed to crack the examination. So do not forget to follow us, subscribe us, and the button below, hit it. And remember, guys, we are there to help you. And those of you who are very new to this family, let me tell you, I'm Shreyas, and I have been teaching for quite some time, producing lots of ranks, training all the kids for cracking their examinations in the 11th and 12th, be it Olympiads, be it JEE, be it NEET, be it board examinations, doesn't matter, be it BITSAT. And many of my students are in the topmost institutes in India, and I hope to do so with you guys as well. In case you want to get in touch with me, you know how to do that. And in case you do not know, let me tell you, you can contact me on my social media handle, that is Shreyas_Vedantu, and that's my Instagram handle. So I keep posting a lot of videos, a lot of interesting stuff, all the important updates, etc., about me, JEE, and every other thing related to science, physics, and everything around us. So do not forget to follow me on Shreyas_Vedantu. That's my Instagram handle. So I hope you guys are doing good. So Ryan from Kerala, hello Mejur, Ensai, Aishwarya, welcome. A lot of new students as well out here. So hi Sneha, thank you so much for all the love. Oh, Uncharted, the Josh is very high. Very good, very good, very good. 17S, glad you're here. You guys have been so regular, and that's what is very important. So guys, let me also tell you the timetable for this week. So we are going to start uploading the timetable just like we used to do before, so that you know what we are going to do in advance. So very good bets, Joji. All right. So Monday, Tuesday, Wednesday, like I told you, 11th standard portions. So today we are going to do rolling, slipping of rigid body. Tomorrow we're going to do all about angular momentum and energy related problems in rotation. And on Wednesday we're going to do lots of problems of angular momentum conservation, torque, etc. in rigid body mechanics. So you can see how well we have planned it. A lot of you I know have commented in my previous videos, can you do one shot series? So guys, understand, if I do one shot, I won't be able to give you so much time. And if I do one shot, I will complete all the syllabus in the next 20 days or 15 days. Then what will you do after that? Do you think you'll really understand everything? No, right? So that's the whole purpose of doing everything in detail. But I have planned everything till January end, February, whatever, so that all the portion, all the topics are going to get covered. So do not worry. 11th as well as 12th, both 11th and 12th, both are going to get covered. So on Thursday, Friday, Saturday, the continuation, lecture 2 of current electricity. In case you have missed the first lecture, check it out. Last Friday, I have started current electricity. we have completed electrostatics in my previous sessions as well. Then we're going to do all about current electricity. So this is the timeline for the next week. We're going to do Wheatstones, we are going to do combination of resistances, Kirchhoff's laws, and all the electrical instruments, etc., etc. Everything we are going to cover, do not worry. And after that we are going to go to capacitors and stuff like that. Yes, so remember, a lot of you also asking for the advanced lectures, the problem solving sessions. Guys, do not worry, we have the mega sprint Menti series. So the Menti quizzes are meant to test your knowledge for all the aspirants of JEE. Guys, it's very important you attend these Menti quizzes. So this week I'm going to conduct Menti quiz on circular work, power, energy and center of mass. That's 11th standard topic, so it will be beneficial for both 11th as well as 12th standard students. So very good problems, and just like last time, we are going to give you the Menti code. You just have to log in and you're going to see points real time, and we are going to compete with each other, and I'm also going to give you the solutions. So this will be a problem solving series. So guys, remember, Thursday 12 p.m. that's what the time is, so you should know that. All right, I hope you guys are liking this new timetable, and I hope you guys are going to follow each and every bit of what we are going to do at JEE Enthuse, because that's your only way of cracking the JEE examination. Let me tell you that, because many people take shortcuts, they do very small lectures, or do not plan in advance on how much time it's going to take to cover all the lectures. So guys, we have planned it all, so do not worry, everything will be over before your exam. All right, so let's get going then. And do not forget, in case you are new to this session, you have to subscribe, and if you're already subscribed, then you have to like, because without your likes, understand, your dues will be remaining. So you have to do your bit. You have to like this video, only then I'm going to get my energy, guys. And if you're new, the way to get your membership into JEE Enthuse is this free subscribe button out there. So hit that subscribe button. All right, yes, so let's get going. Ramchand, so I have converted the advanced problem series into Menti quizzes. So understand, Menti quizzes is real time. Rather than showing you a recorded lecture, I'm going to do it live. So all the advanced problems I'm going to conduct during the Menti quizzes. I hope, Ramchand, that makes it clear. Yes, so thank you, Pranuti. Sneha, what happened is I got many messages, and I saw that many of you are relatively free between 12 to 1 p.m. So that's why I kept it for 12 p.m. So 12 p.m. generally most of you have lunch breaks, or the school, colleges, etc. are over. So that's why Menti at 12. All right. So I hope I have answered all your questions. So guys, that's the advantage of live sessions. I can actually interact with you rather than having a recorded lecture. I do not like personally any recorded lecture. So I prefer conducting live sessions, especially when I'm teaching, etc. Thank you, Satish. Yo. Thank you, Saurav. I hope you liked it on Instagram. So guys, let's start rolling now. So look at this wheel. Probably it has come out from a car. And look at this other wheel. I think I showed you this GIF or animation sometime back in one of my last sessions. So this is a rolling wheel. Now, what do you mean by rolling? Now, I know you have that sensation, or you know what it means by rolling, but exactly what is rolling? So that's what we are going to do today. Yes, Uncharted, I'm going to give you homework problems here. Remember, I always give you homework problems. So Uncharted, so please start doing those homework questions, and I'll also try and post some questions on Telegram group. So hopefully that will be good. What say, Uncharted? All right. Okay. So let's understand rolling, and this is a very unique way, because this is my way of understanding things and explaining things. So look at it. You will get it very easily what rolling is. After this, you will never have confusion in your life. Okay, what is rolling, what is slipping, or what is skidding? Okay, so let's understand. Now just imagine there is a surface, it's rough maybe, and you have a square or a rectangular object, and it is toppling over, and every edge touches the surface and it topples and rolls, something like this. So this is your squarish, rectangularish object. It is toppling over this edge, and this edge is going to remain there only until this face is going to fall flat and this edge is going to touch over here. So it's going to come down like this and it's going to come down like this. Notice while this is happening, this point is not at all moving, it's stationary, and then the face falls flat, and then the cube or the rectangle or whatever it is, it's now going to topple about this point, and now it's going to lift off like that. This edge is going to stay at rest, it's going to start rotating, and then it is going to start rotating about this edge. This edge never moves until that edge until that face falls flat and this new edge is in contact, and the previous edge will leave the contact and it will start again toppling over here like this. I hope this is clear. Oh, the video is not blur, Ankit. Maybe I think internet speed has gone down, Ankit. Just check your internet speed. Sometimes what happens is your internet connection might be slow, because of which the video goes into 240p or 144p. That's when the video becomes blur. So just refresh probably and just check your internet connections and make sure it is at least on 480p to 720p. All right. So Ankit, I just gave the timetable. Just check it out. You can just probably replay the session. I have given the whole week's timetable, plus it's already mentioned on Telegram. So just check it out over there. All right. So now if you understand this, what if instead of a square I had a pentagon? Imagine the same thing would happen, just that it would happen more frequently because it has 5 edges rather than 4 edges. Correct? Every edge will come to rest and it is going to roll over those edges. It's going to topple over those edges. Similarly, I can make that pentagon into a hexagon, and you will have 6 edges which will come to rest sequentially one after the other, and each time that figure, the geometrical figure, is toppling over, right? Something like this. It's toppling over. Understand that edge remains at rest until the next face comes and falls flat. So what if I keep on increasing the number of edges and finally I make it into infinite edges, and that's what is going to make it look like a circle. So circle is infinite edges, remember? So what is a rolling wheel? It's nothing but an infinitely sized polygon or infinitely sided polygon, which is nothing but a circle, which is toppling over its edges. So how many edges does circle have? Infinite. So a circle is toppling continuously and it is rolling over. So that is the meaning of rolling. I hope this is clear. Is this visualization very, very clear? That's the best part about it. Very good. Very good. Amazing, Ankit. Good. You set the video quality. So guys, always set the video quality at least to 480p. Amazing. So which shape have most rolling motion? So Saurabh, the thing is, we generally discuss about wheels, spheres, cylinders, circles, etc. in rolling motion. Although this kind of motion is also kind of a rolling only, but we do not discuss in JEE the rolling or the topplings of squares or pentagons or hexagons. So that is what rolling is. Now let me make you visualize slipping. Observe this car. The car has jammed his brakes, and because of which the wheel is hardly rotating or spinning, but it is sliding. Just like when you press the brakes really hard, the wheels get locked and they drift. Alright, I'm pretty sure most of you would have seen it in some movie or the other, or probably, I hope not, you have not experienced it, but still you would have seen somewhere. Look at the other example. One of the wheels of the car happens to pass over a puddle which is slippery, so the wheel spins and hardly translates. You would have also probably experienced this kind of motion somewhere or the other, or at least seen it in some movie or maybe on TV somewhere. So both kinds of motion are examples of slipping or skidding. Yes, so suddenly when you accelerate and there is a burnout, like it happens in Fast and Furious, the wheel starts spinning and that screeching noise comes and the wheels spin, and then you'll see the vehicle go ahead. You would have seen that, especially in Fast and Furious. And if you have watched Tokyo Drift, I'm pretty sure you would have seen this kind of motion where the tires get locked and the vehicle is skidding on those roads. What an amazing movie that was. How many of you loved that movie? Yes, some of you have already loved that movie. Yes, in sand or in a puddle also the wheels start spinning at that own place. So that is also an example of slipping or skidding. Now to make you visualize that, again let me get back to that same example, but this time notice one small difference from my previous diagram. So what you will see is, again you have that squarish or rectangular or cube or whatever it is, and it is again toppling, and this is the edge about which it is toppling, but there is a small change. The change is this edge won't remain at rest. In fact, it will be in motion. Yes, so it has overcome static friction, and that's why it is in motion. So it is toppling, and simultaneously it is also translating. So you will see that edge will move as it topples, or it performs rotational motion, and it falls flat on the face. And notice how the edge has moved ahead. Isn't it making things very clear? And now again, this is the new edge about which it is going to topple, but that edge will continue skidding, and it will topple more. The edge keeps shifting as the body keeps moving ahead, and the next edge comes over, and that's how it moves. Notice the difference from the previous diagram. The edge is, or the point of contact about which the polygon is toppling, is itself sliding. That's a big difference. So now instead of a square, if you had a pentagon, this would happen 5 times in one rotation, and you can do this more frequently by converting that pentagon into a hexagon. So now you have more sides which are toppling, but remember, every time that polygon topples, that edge is continuously moving. The edge is not at rest, like in the case of rolling. And finally you can convert it into infinite sides. That's nothing but a circle. So a circle or a wheel which is slipping, the point of contact is not at rest, it is in motion. So that is the meaning of slipping. Is it now very clear what is the difference between slipping and what is the meaning of rolling motion? All right. Suhas and Sushil, I just explained, if you just rewind my session, I just explained why one-shot videos never are useful for people, because they never help you gain marks when you have time. When you don't have time, then one-shot videos are amazing, but when you have time, one-shot videos are never useful. They are just crowd attracting videos, but they never actually help students, especially when you have a lot of time before the examination. All right, okay, yes. Now let me tell you more about rolling and slipping. Understand guys, rolling motion is actually translation plus rotation. Yes, and I'll tell you how. Observe this again. This wheel is just rotating. Now this wheel is just translating. It's not spinning. Now if you combine both, it will roll, it will spin as well as translate. So this is spinning motion. It's staying there. Now you superimpose sliding motion or translational motion. Now you combine both the effects, you will see that is nothing but rolling. Is that clear? All right. Now let me show you the velocities of different points in case of translation and rotation combined. See, rolling can be seen in many ways. One way was what I showed you just some time back, which is translation plus rotation. Another way was seeing the toppling of a polygon, one edge after the other, which I showed you just some time back. There are more ways also. So when you think of rolling as translation plus rotation, just first think about pure translation. Imagine a wheel which is just sliding like this. It is not having any angular motion. It is just translating like this. So whatever is the velocity of the center, that is also the velocity of this point, this point, this point, this point, and every other point on the wheel. So the wheel is right now not spinning, so it is just translating. So all the points have the same velocity. Understand that. Now imagine just spinning motion. So the center stays there. All the points move like a fan or like a propeller or like a merry-go-round. So each point has tangential velocity. This is something what you have seen in circular motion. And this velocity obviously will be omega into r. What is r? The distance from the axis. Now if you are here, this velocity will be slightly less. So the farther you are, the higher is the speed. Understand that. So all the points have tangential velocity only because of rotational motion or just spinning motion. Now if you superimpose both the motions, just like the animation I showed you just some time back, notice this one, rotation plus translation combined, then what you should get is nothing but the rolling motion, and that's what you're going to see. So translation and spinning motion combined will give you the rolling motion. Now what is very important for you to understand is, observe each point one by one. Let's take the bottommost point first. The bottommost point, which is also the point of contact, has two kinds of velocities. One because of translation, second because of rotation or spinning. Remember, when any object rolls, the point of contact must be at rest. Remember that edge should not move. So that means these two velocities should cancel out each other, and hence what you will see is the velocity at the bottommost point or the point of contact will be 0, because that's the edge about which this sphere is toppling over. So that's why it is shown to be at rest. Now similarly, look at, let's say, the center. The center is moving with the speed vc, but because of spinning motion it does not have any tangential velocity. So guys, if I ask you what is the speed at the center of the fan, obviously the answer is 0. So there is nothing over here, but the velocity over here, just because of translation, is vc. So what you will see is this point has a velocity of v. Notice that. So this point has velocity of v because of translation, not because of spinning. Now consider this point. This point has, this point has forward motion because of translation, but it also has tangential motion because of rotation. So velocity here and velocity here will superimpose and you will get root 2v. Why should you get root 2v? Because vt and vc are equal. Now you'll be like, sir, why are vt and vc equal? Very simple, guys. Think about it. At the bottommost point, shouldn't both these velocities cancel out each other? That means the magnitude of vc and the magnitude of vt should be equal. Only then this point will come to rest. So understand, vc, vt, etc. all the speeds are same in case of rolling motion, because you will see the point of contact should be at rest. I hope this is clear. All right. Yes. Now similarly, if you look at the topmost point, because of translation has a velocity forward, and because of rotation it has a velocity forward. So at the topmost point will have 2 times the velocity as the velocity of the center. Similarly, the velocity at this point is downwards because of tangential motion, and it has forward motion because of translation. So the vector sum of this and this will give you root 2 times of velocity. So that's how you find the velocity of any point on a rolling object. Rolling wheel, rolling sphere, rolling disc, rolling cylinder, doesn't matter. I hope this is very, very clear. Yes. So if it is not rolling, then it will be stationary or it will be slipping, one of them. So right now we are not discussing slipping. Slipping I will be coming to it in detail again in some time. All right. Rolling is not equal to rotation. Who is there? Saurav. No. Rolling is translation plus rotation. Understand that. Rotation means just spin. So that's the difference. Alright. Ankit, that answer I have already given in friction chapter, static versus kinetic friction. So you should just replay that part. I have mentioned it, why it is easier to move it when it is already in motion. Alright. So now let me give you another perspective. I have already given you 2 perspectives of seeing rolling motion. What was one perspective? The toppling of a polygon. That was one perspective. Second perspective, looking at rolling as translation plus rotation. That's your second perspective. Now third perspective is actually an extension of the first perspective only, if you think of it. Rolling is nothing but toppling of a body about the edge or the point of contact. Correct? So rolling motion is nothing but the toppling of that object about the point of contact. The point of contact keeps shifting, so the body keeps toppling over the edge and next and next and next and so on and so forth. So yes, so without rotation it would just translate. So without that spin, understand, it will just translate. It will not have any spin motion. So now look at this animation, things will be very clear. Look at this rolling body, look at that blue axis. what do you think that blue axis is? What do you think that blue axis is? That blue axis represents the toppling axis. So that sphere is toppling continuously about that axis. Look at that. That blue axis, which is also on the ground or on the horizontal plane, is the axis about which the sphere keeps toppling. There are infinite edges in that circle, remember that. So that axis about which, you know, a body topples and appears to just rotate, no translation, just appears to rotate, that is called as the instantaneous axis of rotation. Very important, very important. So this is the axis about which the entire body is just toppling, it is at rest, and the entire body is just rotating about that axis. So that is why it is called as the instantaneous. At that instant, the body is rotating about that axis. So very, very important. Now what is the use of this? The use of this is, guys, so if that blue axis is the axis of rotation, all right, so the entire body appears to topple or rotate or spin about this point. So it's as if somebody has fixed an axis over here and the body is just rotating about that axis. So that is the reason why you will see all the velocities are perpendicular to the line joining the point of contact and any other point. So let's say, for example, this point's velocity, you can find it by just joining a line from the axis of rotation to that point and going perpendicular. Remember, that's how it is. In your fan blades or propeller blades, any point's velocity is always perpendicular to the radius or the line joining the axis and that point. So all the velocities are tangential, perpendicular from the axis, the line joining the axis and that point. So that's what it is. So it's as if there is an axis here and the velocities are just perpendicular to this rotational axis. No, Earth is not an example of rolling motion because you know, you should have a surface on which you can see some point is at rest. And also there is a specific condition for rolling. Just because an object rotates and translates does not mean it is rolling. Understand, it should rotate as much as it translates so that, you know, the point of contact is at rest. So that is a very important criteria. So unless and until a point of contact is at rest, it is not considered as rolling motion. So very important. Yes, Yamdala, why not? So this is very important, guys. What is important over here is that if you have any body and this is, let's say, the axis of rotation, so if this is the axis of rotation, then any random point, let's say I take a point P here, okay, this point P's velocity can be found by just joining a line like this from the axis and just drop a perpendicular. This is the velocity of point P. And if somebody asks what is the magnitude, that's simple. If the angular speed is omega, then understand Vp is nothing but omega into r. So that is the speed of that particle. A particle here will have a speed here and different magnitude. So same way over here as well, if you take any random point, just draw a line r and the velocity of that point will be perpendicular. So the velocity will be omega into r. So what is that r? Not the radius. R is this distance from here to here. Understand that. So it's always going to be perpendicular. Why? Because this is the axis about which it is toppling or rolling or rotating. I hope this is clear. Everybody understanding it till this point? I've explained it to you via 3 different perspectives. Thank you, Santur. So very important thing. Imagine guys, if I talk about this velocity over here, okay, this is radius r. So this velocity will be omega into r. I hope this is clear. This velocity will be omega into r. Now, if I move slightly up, okay, if I move slightly up, let's say from here to here, this will be 2r because this is the diameter. So this velocity should be omega into 2r. Now think about it. If it is omega into 2r, omega r itself is v. So shouldn't this be 2 times of v? And didn't we get the same answer even via some other method? Remember that rotation plus translation, we got the topmost point velocity was 2v. Correct. Similarly, this point will be at a distance of how much? Think about it. If this is r, this is a right angle triangle, this will be 2r. Think about it, this will be 2r because this is r and this is r. So how much would this velocity be? It will be omega in, oh sorry, my bad, this is not 2r, this is root 2r. Root 2r, correct? If this is r, this will be root 2r, that's the hypotenuse. So the velocity will be omega root 2r. Oh, but omega r itself is v. So this will be root 2 times of v. This is exactly what we got previously in my other perspective as well. So you will see these are just matter of perspectives. You will get the same answer. It's up to you which method you feel comfortable in and which you think is more convenient at that point of time. But you should know everything. Is that clear, everyone? Spare time because of Pythagoras. If this is r, this is also r. So what will this be? R square plus r square's root. So that's why it is root 2r. Very good. All right. So let's get going then. Clear? Okay. So let's quickly revise what we have done till now. So we have seen before this. All right. So what is rolling? Rolling is nothing but toppling of a polygon. All right. Of infinite sides, where that edge. All right. That edge is nothing but at rest. So the object keeps toppling from one point to the other, but the edge remains at rest. So you can make that square into a pentagon, hexagon, or a circle. Whereas in case of slipping, that edge keeps shifting away like this. All right. So that is called as slipping. And the same thing will happen when you make that square into a hexagon or a circle. You can also see rolling as rotation plus translation combined. So that will give you the combined effect, but in a specific manner. Not any rotation will give you that. So what is that specific combination? When the translation and the rotation combined are in such a way that the bottommost point's velocity is 0 when it is at rest. Only then it will be understand rolling motion. If this point is not at rest, it will be slipping motion. So another perspective was looking at the instantaneous axis of rotation, which is the point of contact. That's in the case of rolling motion. Very good. Now let me differentiate between rolling. Then there are two kinds of slipping. Not many people understand it very clearly, and that is why I'm going to give you an amazing table, and we are going to solve plenty of problems today by which all your concepts will be very clear. So pay attention carefully till the end of the class. So there are three ways in which you can categorize these kind of motion. You'll be like, why three ways? I thought it was just rolling and slipping. No, one is rolling. The second one is called, forward slip, and the last one is called backward slip. So there are three kinds of motion possible when you combine translation and spin motion together. So rolling, forward slip, and backward slip. So what's the difference? So first let's get three rolling spheres or wheels or cylinders or any rings, doesn't matter. Now these are three wheels, but the manner in which they move, the manner in which they translate and rotate is going to decide whether they are rolling, slipping forward or slipping backward. So what is going to be different? Well, all the wheels might have the same velocity, might be moving in the same direction. All the wheels might be moving in the same direction, but there is one small difference which will distinguish between the three. Does anybody know what is the difference? Does anybody know what's the difference? Okay, come on guys. All right, Major understood, very good. So guys, the difference is, come on. 1 second, let me just read your chats. Yeah, okay. Some of your chats were missing. Okay, anyways, so now I'm able to see everything. All right, no, not gravity. It depends, no, not on the friction. It depends on the point of contact. Which direction is the point of contact moving? So look at the point of contact. So if the point of contact, guys, if it is at rest, 1 second. Yeah, if the point of contact is at the rest, then it is said to be rolling. I just told you an object which is toppling, the point of contact should be at rest. only then it is said to be rolling. Very important, keep this in your head. I'm going to give you many more pointers. Next, in case of forward slip, where will the point move? Where will the point move? The point should move in the direction, alright, in the direction of the motion of the center. So wherever the center is moving, it should move exactly in the same direction, parallel to it. It need not be equal. The speeds may not be equal. That's okay. But the directions should be same. That's all. So then it is said to be forward slip. Can you think of an example of forward slip? I'll give you an example. If you brake very hard, then understand your wheel's center is moving forward and even the point of contact is also moving forward. Correct? When you brake really hard, the wheels get locked, they're hardly spinning, and you will see the wheels just, rub against the road, and you will see the point of contact moves forward along with the center of the wheel. That's a very good example of forward slipping. Another example which we are going to solve at the end of the class today is bowling. If you have bowled, if you have gone into a bowling alley, you get those big hollow shells or spheres, and you would have held it using your 3 fingers or 4 fingers, and then you throw it. Have you done bowling any time in your life or seen it in movies or something? You will see when you throw it, alright, it hits the surface, it slides for some time, center moves forward, even the point of contact moves forward, and that is forward slipping, guys. I hope you are getting the feeling, the sensation of this. Spare time, maybe you can watch the video later on. Alright, bowling, you can just check it out later on. Alright, for now just understand it's a ball which you throw and it hits some some bottles, and you have to make these bottles fall. The more the number of bottles fall, you get more points. That's all. Okay, so that's one example. Backward slip means the velocity of the point of contact should be opposite to the velocity of the center. So the vehicle or that wheel is moving forward, but the point is moving backwards. Example, imagine your vehicle is stuck in some sloshy, muddy surface or slippery surface, and because of which the wheel is spinning a lot, but it is hardly moving ahead. It moves slightly forward, but the point of contact moves more back. So that is a very good example of backward slipping. I hope this is very, very clear now. Okay, walking is not an example of these things. Understand, these things are categorized only for round objects, not for any other shaped objects. So I'll just give an example. So I will say example wise, this will be normal motion of wheels of a car or a bike. This is normally your wheels never slip. Okay, it's bad for the tires and for the engine. Forward slip, the example is when you brake. So when you brake hard, so when you brake very hard, so that's when the tires slip. That is forward slip. Backward slip is burnout. Accelerate very fast, or basically burnout. During burnouts, that's what you get. Okay, very, very important. Now, if you have understood till here, please understand next pointer. The velocity of the point of contact is 0. That means the velocity of the center should be the tangential velocity, which is nothing but omega times of r. So the VC should be equal to omega r, very important. Only then the forward velocity and the backward tangential velocity. Remember, VC is forward, V tangential is backward. They cancel out each other. That's why the point of contact is at rest. So in this case, velocity of point of contact should be parallel to the velocity of center. That's the essential condition. And for this, the velocity of point of contact should be anti-parallel to the velocity of the center of the wheel. So very, very important pointers. Next important pointer is the friction that acts in case of rolling is always static in nature. So there should be always static friction over here. Reason? Because remember, this point is not moving. This is stationary. Remember an edge toppling over, remember a polygon toppling over an edge. That edge is at rest. It wants to move, but it is not able to move. So the friction is static in nature, and it can be anywhere between 0 to Fs max. I do not know how much, but it can be anywhere between 0 to Fs max depending on the tendency to slide. Whereas in this situation, the friction will have to be kinetic in nature. Think about it. So kinetic friction will act, and this will be mu times of n. Kinetic friction. Why? Because there is actual skidding or actual slipping. So when you brake really hard, there will be actual skidding of the tires. Alright, so remember that. Very good. Fanta clear. Okay, but Fanta's slogan is something else, I think. Anyways, so where would the friction act? Guys, obviously if this point is moving forward, the frictional force will be in backward direction. Understand that. So let me just put it over here. Okay, so this friction will be in this backward direction. I just shown the arrow mark because I don't want to mess up the diagram out here. Because remember, friction, kinetic friction always opposes relative motion. So if the object is moving this way, the friction will act backward. And the last one, again, this will be kinetic friction, guys. This will be mu k times of n. But beware, this time the point of contact is moving back. So the friction will act forward. So kinetic friction will act in the forward direction. Is that clear? Yes. Exactly, guys. I hope this is clear. Last pointer out here. Last pointer out here. Okay, the last pointer out here is that in this situation, there is no work done by friction. You might think friction is there static, but it will not do any work because there is no rubbing. See, when you rub your hands, you feel the heat, correct? You feel the heat. Rub your hands and see, you'll feel the heat. But just touch your hand, static friction, I don't think it's going to do any work. So this static friction, when an edge came out, you'll see that body toppling, there is no work done by the friction over there at the point of contact. So hence, there is no work by friction, static friction. Alright, this was the static friction, and hence that implies mechanical energy can be conserved. So if you need to conserve mechanical energy, I'm not writing it here, but that's understood. If friction is not doing any work, obviously mechanical energy can be conserved, assuming other forces are not doing work. Now, in this case, kinetic friction, oh, it's bad. There is slipping happening. Imagine the tires rubbing against each other. There will be some rubber on the road. There will be some heat generated. Even during burnout, you would have seen some rubber on the road. There is some heat. The tires get hot, etc. So where did that energy come from? Obviously, the friction is the evil guy, and it's going to do negative work. It's going to suck away all the kinetic energy from the wheels or from the engine. So that's where the heat comes from. So I will say negative work done by, it's a common point for both the things, so I'm going to extend it over there, by kinetic friction, which gets converted into heat. So some heat is generated because of this. So very, very important pointers, guys. So I hope you have made notes simultaneously, because it's very important that you make notes while you are attending these sessions. All right, very good, Ankit, very good spare time. Thank you. Let's get going. Yes, Sarthi, clear, very good. All right. Shall we go ahead now? Shall we do some problems? Got it, Uncharted? Yes, done. Very good. So, one more thing before we go to some problems. This is something again where not many people touch upon these ideas, but see, I am going to teach. I just promised all you guys that I'm going to teach you all the concepts. If I wanted, I could have very well planned. I have done this before because there was very little time left before the exam. I can complete the entire syllabus within 10 days, but I'll assure you, you will not understand anything. You will just be like, the syllabus was done. Completing the syllabus, covering the portion, yes, done. But that's not what we are here for. We are here to uncover the portion, understand, to uncover the knowledge, to understand everything. That's what we are here for. So we have time. If there was hardly 5 days or 1 week before the exam, yes, I would have stayed with you all night and I would have completed the entire portion. But there is no point in that. All right. So now one more important thing about the acceleration perspective, guys. Yes, spare time, I will definitely do that. Yes. Perfecto. Yes, Dinesh. So here it comes. The center's velocity might be forward, so even it might have some acceleration. Maybe it is accelerating as it rolls. So if the center has some acceleration AC, all right, and as it rotates, the angular velocity will also change. So it will also have some alpha. So understand, if the center had velocity v, c and angular velocity omega, we know that v is equal to omega times of r. If it is rolling, if it is a rolling object, v is omega r. Now differentiate both sides. You will get dv by dt is equal to, omega is a constant, omega is not a constant, r is a constant, d omega by dt. Omega is changing because of that acceleration. What is dv by dt? The acceleration of the center. This was of the center, remember, and this omega was of that object out there. So it was r into alpha. So this is true in case of rolling. So when the object rolls, a, which is the acceleration of the center, will be equal to r times of alpha. But this might not be true. This might not be true in case of slipping, because in slipping, v is not equal to omega. Understand that. All right. Great. Okay. So one more interesting thing. Imagine I ask you, what is the acceleration of the center? What is the acceleration of the center? Assuming, let's assume few things. It's moving with velocity v and it's spinning with angular velocity omega, and this v is constant. Let's just assume that it's moving with constant speed. If I ask you what is the acceleration of point C, you'll be like, come on, it's very simple. Acceleration of point C is nothing but just the acceleration of the center, which is just a. And is it actually accelerating if v is constant? Well, I don't think so. Think about it. dv by dt and I cap because it's moving in the forward direction, this will be 0. So it's basically not going to accelerate if speed is constant. Only when the speed increases, that's when the center will have some acceleration. Is this point clear? Is this point clear? Now, if this is clear, think about this. What if I mark a point A over here? This is a point A, and I ask you, what is the acceleration of that point A? Now this will be some crazy problem, and I'm going to make the problem more complex in the remaining questions, you will see. Now imagine if I want to find the acceleration of point A, it's not so simple. So you know what I'm going to do? I'm going to change my perspective. What is rolling at the end of the day? It is spin plus translation. So why not sit on the center and then look at point A? If you sit on the center and then look at point A, it will appear to perform circular motion, correct? But you yourself, when you are sitting at point C, you will be moving with velocity v, correct? So can I not say acceleration of point A is acceleration of A with respect to C plus acceleration of C itself? Do you remember this was the definition of relative motion? A12 is A1 minus A2. So A1 is actually A12 plus A2. We have seen this before. Why are we imagining this, Survinder? Because it's easier to solve the problem. In fact, that perspective was given to you because rolling motion can be perceived as rotation separate and translation separate, so that the problems become easier. Now I'm giving you the application of that, why you should separate it out, because it will look easier. That's what you're going to see. All right. So now what we are trying to do over here is to find acceleration of A. We have separated rotation and translation separate. So when you sit on C and observe A, it is just the spin that you will see. And when you just look at point C, you will just see the wheel or just that point translating. So this is just the translation part, correct? Now think about it. Is that clear? Is that clear? Thank you, Survinder. Now, if this is clear, think about it. If you are at the center C and observe that point A, it is going in a circular path. Isn't it going in a constant angular speed? So if it is going with a constant angular speed, isn't it uniform circular motion? And what happens to a particle performing uniform circular motion? It only has centripetal acceleration, correct? So it has centripetal acceleration as it moves in that circular path. So this particle A will have centripetal acceleration. So I'll call that A centripetal. All right. And this center will be moving forward. But hold on, this velocity is going to be constant. So what will be the acceleration of center C? It will be 0. 0 because V is given to be constant. Amazing. So now if this is clear, what is the value of the centripetal acceleration? Guys, isn't it omega square r? So that's it. The magnitude wise, it is omega square r. But at this point, where would it be directed? Downwards. So I can just put a minus sign with j cap, because this is my x-axis, this is my y-axis. So minus because it's downwards, and that's the acceleration of point A. Isn't it a fascinating problem? Yes, it is in uniform circular motion. There is no tangential acceleration because it is not going non-uniformly. All right. So very, very important slides, and making you visualize circular motion, rotational motion, spinning, translation, everything together. So a lot of important things. So let's get going to problems now. Now before we go to problems, let me also tell you, for all the 11th standard students out here, all right, so those of you who want to still join Vedantu long-term courses, Vedantu still has long-term courses at any point of time. So understand, right now also there is a long-term batch which is going to start, and that will also have live online two-way teaching along with a master teacher and multiple class teachers. Each class teacher helps assist a small group of students and solves their doubts in the class itself. So the job of the teacher will be to teach and to also interact, conduct quizzes, leaderboards, and so many other amazing things. Along with that, the class teacher will help the students solve their doubts, and in case some doubt is persistent, the class teacher passes on that doubt to the main master teacher, and the master teacher will solve the students' doubts. That's how what happens. And post the class, if you still have doubt, there is in-app doubt facility where all our subject matter experts answer to all your doubts, queries, no matter which topic it is on, based on 11th and 12th standard portion. And you can also interact in our groups, closed groups, with other students as well as your main master teachers. And also you will get amazing assignments after every lecture that is conducted. And also you will get the modules, the Tattva module, and you will also get national level test series, so that you get to know where you stand nationally and not locally, because the students in your class will be from all over India. Remember that. So after that, you also get report cards which tell you where you can improve, how you can improve, and stuff like that. And you also get guidance from personal teachers, which is a very unique thing. These are special counselors to help you boost your performance, and they will plan timetables. They will help you emotionally as well as help you in your studies. Those are personal teachers which you can also opt for. And understand, if you're still wanting to learn more, there are hundreds of micro courses, like the one I conduct in the pro subscription is a numerical course, a physics numerical course which contains all the numericals from 11th standard, and there is a derivation course for all the derivations, and then there is a H.C. Verma course for discussing all the H.C. Verma short answer questions and also give you the exercise solutions. So all these are the micro courses that you can benefit for free. You don't have to pay anything extra for any of these once you are in the pro subscription. So if you are wondering what is the fee, here it is. Generally people will go for 6 months, that's why I'm telling you the 6-month price. But if you want to try it for 1 month, no harm in it. So for 6 months, it's 24,000, but 20% offer is going on, and because of which the 24,000 course will be available to you only for 19,200 rupees. And the work and it works out to be around 107 rupees per day, which is very, very, very cheap. Now, if you go for this course 6 months, remember, the entire syllabus will be done before you enter your 12th standard, and I'm pretty sure you will be in a much better state than what you are today. And the way you can enroll and get that discount is after you use this coupon code, and when you click on the link below in the description box. So go ahead, click on that link, see whatever is there in that course, or get all your questions answered. You can talk to our representatives, and also do not forget to use this code, because nowhere else on Vedantu you will get a higher offer than this. Remember that. So the coupon code is SHHPRO, 20% flat off. You can also give the code to your friends, relatives and cousins. Alright, so let's get going. Let's get going to some problems, okay? Alright, I hope the Josh is high. The Josh is high, guys. And here's the first question on your screen. A bicycle has a big tire in the front and a small tire at the back. Which of the following has more angular speed, and which of the following the center of the wheel, which wheel center has more velocity? Come on, let me know in the chat box right away. Ready? Very good, spare time. Let's get rolling, Science Priya. Very good, very good. Come on. Which wheel has more angular speed and which wheel center has more speed? Come on. That's the question in front of you. Okay, the time should be up now. Okay, so let me tell you guys. Come on, come on. Big tire. No problem, Ankit. No problem. Big tire. So let me tell you. Both the tires centers. Alright, both the tires centers, V1 and V2. These both, V1 and V2, should be equal. Like, what the hell? Why? Obviously, if they are not equal, that means, think about it, this solid part, if this is moving faster and this is moving slower, then that frame will start opening up. Think about it. If the both points do not have the same speed, then the frame will open up and it will break. So there cannot be any relative motion between the two. So V1 has to be equal to V2. Very important. Now let's talk about angular velocity. Omega 1, and this is nothing but omega 2. So V is nothing but omega 1 R1 and V2 is nothing but omega 2 R2. So just rearrange, you will get omega 1 by omega 2 is R2 by R1. Now who is more, R1 or R2? Obviously R1 is more. So R1 is more, R2 is less. So understand, omega 1 is nothing but less, and omega 2 is more. So the bigger wheel has less angular velocity and the smaller wheel will start rolling fast, and that's why it will have more angular velocity. Very, very important, guys. Very, very important. Okay, I hope you guys got it. Both the wheels will have the same velocity for the center, but angular wise, the smaller one will have to rotate many times, but a bigger wheel will have to rotate lesser number of times. Yes, R is not same. That's the problem. Very funny cycle. It used to be there during olden times or probably in the circus, but not now. Alright, so let's get rolling to the next question, and here it comes. Is the wheel at point A slipping, and if so, what type? Given the velocity of the center is 5, radius is 1 and angular speed is 4, what do you guys say? Is the wheel rolling or slipping? And if it is slipping, what is the kind of slip? Is it forward slip or is it backward slip? What do you guys say? Think about it. Think about it. Come on, come on, come on, come on. All right. Is it slipping? No. Yes. Forward slipping, backward slipping, or rolling? 3 options: forward slip, backward slip, or roll. Ankit says forward, Bet says yes, it is slipping, Jumna says backward. Oh wow, very interesting answers that we are getting out here. So guys, let me tell you, because the center is moving forward, this point is moving only because of this VC with a speed of 5 meters per second. Now, because omega is also given and radius is also given, I can find out the tangential velocity, which is omega into r, which is nothing but 4 meters per second. Now because of the tangential velocity, this point will have a velocity backwards like this, 4 meters per second. Now think about it, this point moves forward 5 meters in 1 second, but also moves backwards 4 meters in 1 second. So effectively, what is it doing, guys? I feel effectively this point A is moving with the speed of 1 meter per second forward. It is in the direction of VC, so this kind of slipping is obviously forward slip. Understand? So this is a very good example of forward slip. Very good. So it is not rolling, Saurav. Understand? V is not omega r, plus look at that, the point of contact is not at rest, so that's the problem. So it is forward slip. All right. So let's get going to the next question coming up on your screen. A small change in the data. The center speed is 6. The direction is like that. Omega is that way clockwise. Radius is 2. Angular speed is 3. What is it doing? Is it rolling or is it slipping? And if it is slipping, what kind of slip is it? Come on, guys, come on. Yes, Agni, just look at the point of contact. Remember, I just told you, just look at the point of contact. If it is at rest or if it is moving. That's it. And use the concept of relative motion. That's all you need. Okay, it's very tricky problem, let me tell you that. Okay, so here is the answer, guys. Understand, this VC is given to be how much? 6 meters per second. So this is nothing but 6 meters per second. So this point will move this way with the speed of 6 meters per second. But also simultaneously, because of this angular speed and this radius, the tangential velocity will be 3 into 2, which is 6 meters per second. But which direction will it be? Okay, think about it. Omega is clockwise. So this point will additionally have a tangential velocity of 6 meters per second. Naturally, the addition or the sum of both of them will be 12 meters per second this way. Now you might think this is backward because you're used to seeing diagrams where things go towards your right, but beware, the center is moving towards your left and point A is also moving towards your left, so it's forward slip again. So this is a very good example of forward slip. So understand, V might be equal to omega r, but directions are also important. The wheel is going this way and it is spinning that way. In spite of V being equal to omega r, it is still slipping. So understand, unless this direction was this way or this velocity was that way, it would have been slipping. So if the velocity was there or this omega was the other way, then it would be a rolling situation. Understood, guys? So it looks like it is rolling, but it is not. Very, very important. Very important. So the directions matter a lot. These directions should have cancelled, only then it would have been rolling motion. Understood, guys? Very, very important problems. Let's get going. Now, this is your homework question, guys. This is your homework question. Remember, just some time back I told you, okay, now we're going to do more problems. This is a homework question. There are more problems now which we are going to do inside the class. I told you how to find acceleration of point A or acceleration of point C just some time back using relative frame, using that perspective of splitting the rolling into translation and spin motion. So use that concept and just try to figure out what is the acceleration of A and C. Please understand, unlike before, unless you comment in the comment section after the class, I won't be disclosing the answers in the Telegram group. So it's very important you put up the answers in the Telegram, you put up the answers in the comment section below. All right, so very, very important. So this is your homework question. Read it carefully. You can take a screenshot of this. I just stand away. I hope you have taken a screenshot. Remember, the answer is not so straightforward. It's quite complicated. Okay, so now let's talk about the dynamics of rolling. Just some time back, I was telling you, if an object is rolling, then the friction can be either forward, backward, you do not know, and this friction will be static in nature. So please understand, there could be multiple forces acting on the body. All right, so there could be F1, F2, etc. acting on the body like this, Fn. Now what is important is, the forces F1 plus F2 plus Fn, etc., normal, it could be weight, plus the static friction, this will be equal to mass into acceleration. This is one equation which you're going to use, guys. This is your normal Newton's second law, and the last equation that you're going to use is torque because of force 1 plus torque because of force 2 plus torque because of nth force plus the torque because of friction, all right, will be equal to I into alpha. So these are the equations that you will need to solve the problem, and in the end obviously A is equal to alpha R. So use these equations to solve the problem whenever there are forces involved. Just draw the free body diagram as you do normally. Just write one force equation, just write one torque equation, and do not forget to relate A and alpha, because that's very, very important. Okay, so we are going to see some problems on that, and when there is slipping, please keep in mind that the friction acting will be kinetic in nature. So the friction could be anywhere depending on the nature of the slip. I have told you that before. And again the same thing, all right. So all the forces F1 plus F2 plus Fk will be equal to mass into acceleration, and again the torque due to force 1 plus torque due to force 2 plus torque due to friction will be equal to I alpha. But keep in mind one important thing, A may not be equal to alpha R, all right, because it is slipping. So be careful, A may not be equal to alpha R. So very, very important slide again. Okay, so let's get going. Let's see how many of you get this answer. So guys, there is a solid sphere and it is pushed by a force of 2 mg. What is the friction? What type of what is the friction acting, and what is the direction if it rolls? Okay, so one thing is very clear, guys, that because it is rolling, what does it mean? What kind of friction will act? If it is rolling, what kind of friction will act? Obviously static kind of friction will act because it is rolling. What direction will it act? I don't know. So what will you do? Assume. Which direction? It's up to you. Alright, so let's just assume the friction to be backwards. There is no harm in that. Apart from that, there will be mg force, and of course there will be a normal force. And do not forget, this external force is equal to 2 mg. It's given in the problem. Now what else I need to worry about? Yes, the center will have some acceleration A, and it will also have some angular acceleration, that solid sphere, alpha, like this. So these are the important things, and do not forget A is equal to alpha into R only because it is rolling. Very, very important. Now what do we do? Let's start writing down the equations. F is ma, torque is equal to I alpha, that's all. So let's try this out. So please understand, I do not know what is the value of friction. A lot of people commit a mistake. They write it is mu mg. Please understand, it is not mu mg. We do not know how much it is. We need to figure out using equations. So let's see, how do we do that? Now let's write down the equations. In the x direction, the force is F, and static friction, nothing else is there. Normal and weight are downwards and upwards. So guys, can I say that my external force minus the static friction is nothing but just mass into acceleration? My external force is nothing but 2 mg. This is nothing but Fs is equal to m into A. So this is my equation number 1. Nothing else I can do. Next, what I will do is I can write down the torque equation. So about the center, if I measure the torque, mg will not give any torque because mg is passing through the center. Normal will also not give any torque because that is also passing through the center. The only two forces which will give you torque is this friction force. This friction will spin the wheel in the clockwise direction, and the topmost force is also going to spin the wheel in the forward or in the clockwise direction. So both of them are going to give you torque. So the torque by the friction plus torque by that external force will be I into alpha. Nobody else is going to give you any torque. So what is the torque by the frictional force? It is just Fs, okay, into R. That's it. Because this angle is 90 degree, so R into Fs, sine 90. Sine 90 is 1. Plus torque by that external force, it will be again 2 mg into R. What is the moment of inertia? Solid sphere. What is the moment of inertia, guys? Come on, you should know that. It is 2 by 5 mr square. I have talked about this in detail in a separate lecture. So it is 2 by 5 and m into r square. And what is alpha? Alpha is a by r. Notice over there, alpha is nothing but a by r. So understand this r will get out. This r, and this r will also get out. And what will I have? I'll have Fs plus 2 mg is equal to 2 by 5 ma. So this is my second equation. Now what do I need to do? I'll just add both these equations, guys. So, I can find out the value of A. So let's add 1 and 2. If I add both of them, what will I get? Fs will cancel. 2 mg and 2 mg will give me 4 mg. Check it out. So 2 mg and 2 mg will give me 4 mg. Fs cancelled. Ma plus 2 by 5 ma. 1 plus 2 by 5 is 7 by 5. So it will give me 7 by 5 times of ma. Now gets cancelled and I will get A is equal to, check it out, 4 5s are 20. So 20g divided by 7. So that's the value of acceleration. But that's not it. I want to find friction, guys. So substitute this A over here and that's how you can find the value of friction. So what you need to do is Fs will be equal to, think about it, it will be 2 mg from this equation, 2 mg minus ma. So it will be 2 mg minus m into, acceleration was 20g by 7. So 20g by 7, guys. So 7 2s are 14. Okay, 7 2s are 14. 14 minus 20 is minus 6. So minus 6 mg by 7. Now it's very important to understand the friction value came out to be negative, number 1. Number 2, there is no mu in the answer because it is not needed. So if the friction is negative, guys, what does it mean? It means whatever direction I have assumed is wrong, the friction should be forward. That's all it says. But the magnitude is 6 mg by 7 only. Is that clear how to solve problems? Survinder, you can always assume the friction to be in any direction in rolling problems. Automatically you will get the correct answer. Alright. So look at the signs finally. That's what matters. I hope that is clear. Yes, Aishwarya. Yes, Survinder. Now the friction is in the forward direction. Is that clear, guys? Very, very important problem. Shall we go ahead? Clear, Aarti? Very good, very good. Okay. So now let's talk about an object rolling down an inclined plane. So when an object rolls down an inclined plane, if you have seen this kind of a problem, I'm going to give you a very beautiful formula for remembering this. Very, very important. So if this is a rolling body, the forces acting on it will be mg, correct? But this mg, I'm going to split it up into two components. One component will be here. One component will be here. That would be mg sine theta. Then another component will be here, which will be mg cos theta. And then there will be a normal like this over here, correct? And yes, there should be also friction. But where will be friction? I do not know, but by practice I know it will be upwards. There is one simple logic for this. Guys, if you consider the torque about the center, think about it. Normal will not give any torque. Mg cos will not give any torque. Mg sin will also not give you any torque. So the only force who can give torque in a rolling sphere down an incline is only the frictional force. So now think about it. If it falls down like this, who is going to give the torque this way? Who is going to make it roll like that? Who is going to make it spin? Obviously there has to be something. So hence friction has to act upwards, and obviously since it's rolling, it has to be static in nature. Is this concept clear? Why friction acts upwards? Very, very important concept, because that's the only force which will give torque. Mg cos normal and mg sin will not give any torque. And this has to accelerate, and this has to also have some angular acceleration. This is the free body diagram. Alright, so now, if you draw the FBD, that's it. You just have to write down the forces equation, guys. So Please do not forget the frictional force. mg sine theta is downwards. So mg sine theta is downwards minus friction is equal to m into a. That's one equation. And then you also have the torque equation. So the torque equation will be, oh, normal did not give torque, mg did not give any torque, only torque by the friction. R is radius, F is friction, angle is 90. So R, F, S sine 90, because that is the torque equation, is equal to I into alpha. But hold on, A is equal to alpha R. Why? Because it is rolling. So the moment it rolls, understand guys, A will be equal to, so the moment it rolls, A will be equal to alpha R. So use all this, and finally what you get is, now this is the most important formula. You can solve it just like we did the previous problem. It will be G sine theta upon 1 plus the factor in moment of inertia. If you remember it like this, it will be easy. Lot of books do not give this formula. Lot of books, they give you in some confusing manner. So guys, this is very, very important. Now what is this factor in MOI? Remember, for a disc, the formula is nothing but mr square, half mr square. This half is that factor. For a solid sphere, it is 2 by 5 mr square. So 2 by 5 is that factor. So it's very important to remember the formula in this particular manner. Correct. Correct. So that factor, what I'm talking about, is this one. So for a, for a ring, it is just 1 times of mr square. So this 1 is that factor. Now, you know what is the best part about this? The best part about this is, this factor does not depend on the mass. It only depends on this number which comes outside. So this acceleration of this wheel is independent of the mass of the wheel, and even so the radius of the wheel. It's not dependent on the radius nor on the mass. It will always have the same acceleration provided it's the same object. So if it's a solid sphere, you can take a big solid sphere, you can take a small solid sphere. Both of them will come down with the same acceleration. Understood? But if you take a solid sphere and if you take a hollow sphere, then both of them will come at different times. Why? Because the factor for them is different. Now for a hollow sphere, it is 2 by 3. For solid sphere, it's 2 by 5. So the factor in case of hollow is more, correct? For hollow, it is more. 2 by 3 is more than 2 by 5. So if this factor is more, denominator is more. If denominator is more, this ratio will go down. That means the acceleration will be less. If acceleration is less, it will come down slowly. So a hollow sphere will come down slower than a solid sphere. Remember that. Understood? Now don't believe me? No problem. Look at this diagram. One is a solid, one is a hollow sphere. Observe which one will come fast out of the red and the yellowish one. The one which comes slowly will be the solid one. The one which comes faster will be the hollow one. Understand that. So you can see, out of a ring and a solid cylinder, or a hollow and a solid cylinder, look at that, who comes first and who comes later on. For hollow cylinder, the factor is 1. For solid, the factor is 1 by 2. So when the factor is less, acceleration is more, because factor is always in the denominator. So that's why a solid cylinder comes faster than a hollow cylinder. Very important. Doesn't matter what the mass is, doesn't matter what the radius is. What an interesting idea. I hope this is now clear. Is that clear, everyone? Very good. So, how about this question? If the surface is frictionless, Saurav, then you know what will happen? It will not roll. It will just slip down. Yes, it will just slip down. Correct, correct, correct. Now it's clear. Now, can you solve this problem as homework? So this is your next homework question, guys. You have to find the minimum coefficient of friction to prevent the slipping. Alright, minimum coefficient of friction to prevent the slipping. Hint, use that formula. Which formula? Use that formula. A is equal to G sine theta divided by 1 plus factor use this formula as a hint. This is your first hint. Second hint is draw the free body diagram and look at the torque, etc. and use this word. Minimum coefficient of friction is needed. That means think the friction will be limiting. So pay attention to all this. These are your hints to solve this question. So guys, those of you who are asking, sir, what about some more problems? So guys, I plan for more problems inside the session and I give it to you as homework. So I can give you some hints and I expect you to please put up the answers only. Be it correct, be it wrong, doesn't matter. Or if you are nervous or shy, you can send it to me on Instagram, which is, you know my Instagram handle. It is nothing but guys, Shreyas_Vedantu. So this is my handle, Shreyas_Vedantu. So you can send it to me on that as well. It's up to you. But I would prefer you putting it up in the comment section as well. All right, great. So now, how about the most amazing problem of today? Bowling. So some of you are asking me, what is bowling? So this is bowling, guys. I have kept a slide for that because I knew a lot of you will not be knowing about bowling. So this is bowling. So when you release that ball has translation but no spin. So we are going to solve that problem. No problem, sir, always. Telegram, Survinder, it's a one way, it's not a two-way thing. So that's why on Telegram I'll be just posting the solution, my handwritten solution, properly explained on Telegram. All right, Survinder. Okay, so let's see how to solve this problem. A bowling ball which is hollow, all right, so moment of inertia is 2/3 mr², is given linear velocity at time 0. What will be the time after which it starts rolling? So first it slips, but after some time it will start to roll. So what is the time after which it begins to roll? So let's look at this question. First of all, code red is just for time pass. Don't get confused because of that code red. Okay. No problem. Okay, so now initially it only has linear velocity. Angular velocity is 0 initially. Initial angular velocity is 0. So think about it. This point of contact, correct? This point of contact has motion in the forward direction, correct? This point moves forward. So there must be friction here. What friction will it be? Kinetic. What direction? Opposite. So the friction acting in this situation, guys, will be in this way. This will be the kinetic friction. I hope you can see that. And normal and mg will be obviously there. I'm not showing it. Because of this friction, you know what is going to happen? This friction will give a torque. Look at that. A torque like that. Mg and normal will not give any torque, but friction will give torque. And because of that, you will have angular acceleration alpha. Correct. You will have angular acceleration alpha. And this friction will also give rise to an acceleration, but in the backward direction, guys. Why in the backward direction? Because there is no other force in the forward direction. Normal and mg are down and up. So this friction will cause acceleration and angular acceleration. Is that point clear till here? Yes, no wonders, Neha. Whatever doubt you have, Dinesh, please put it up in the comment section. I'll definitely respond to all the comments. So that's what I do. After the session is over, whatever comments come up on the comment section after the video is over, I respond to all of that. All right. Now think about it. Because of this alpha, you know what is going to happen? Because of this alpha, this omega will increase. And slowly the omega will increase. And what will happen to this velocity? This velocity will decrease because this A is opposite to that velocity. So omega will increase, velocity will decrease till V is equal to omega r. So the moment my velocity and my omega become like this, V is equal to omega r, till that time the change will happen. And once this happens, let's say this time is t1, after that it will roll. It will just roll till here, and understand, for this duration it is going to just slip. So it started over here at t is equal to 0. So this is the situation. This is the situation. Very good, Dinesh. All right. So now, you know what is the equation that I'm going to write? First is the force equation. Friction is going to give you mass into acceleration. So let's write that down. Friction is equal to mass into acceleration. But friction is nothing but mu. Remember, kinetic friction is always mu n. So mu n is equal to ma. But hold on, n is nothing but mg. So therefore, guess what? Acceleration is just mu g. This is one thing I got. Now, let's think about alpha also. How? Torque equation. So take the torque about the center. You will see normal and gravity are passing through the center, so they will not give any torque. The only force giving rise to any torque is the kinetic friction, and it is acting at a distance of r from the center. So r into Fk will be I into alpha. So this is the torque equation. I hope you can see that. Now, what is Fk? Fk is nothing but mu mg. And what is moment of inertia? It's a hollow object, which is a hollow sphere. That means 2 by 3 mr square. So do not forget that. So 2 by 3 mr square. Also, do not substitute alpha as a by r, because it is slipping. Remember, in slipping, a is not alpha r. So please do not substitute it like that. So keep it as alpha. Now rearrange this and you will get alpha is equal to, one of the r goes, m anyways will go, and you will get it as 3 mu g by 2r. Okay, interesting. So this is what I got till here. Now let's see what we can do about this. Now we want to get to this v and omega. How do we get to v and omega? If I know acceleration and if I want to find time, how do I relate velocity, time and acceleration? Kinematic equations. So use kinematic equations, that's it. So v is equal to v naught minus at. That's it. So this is the first kinematic equation. And similarly, remember, you can use the rotational kinematic equation also, which is omega is equal to omega naught plus alpha into t. Now just use that, guys, and remember v is omega r. So just use that. So v naught, therefore I'll put v naught minus a t1, okay, is equal to this omega, understand? So basically alpha t1 into r, so that radius r over there. So that is what I'm going to get. Now it's up to you how you want to solve this. I'll just solve that. Just substitute everything over here. V naught, you just put v naught. A, you put mu g and put t1 over here is equal to alpha. Alpha is nothing but 3 mu g by 2r. So put 3 mu g by 2r and multiply that with that r. Now this r and this r goes. Take that term over there. So you will get v naught is equal to mu g t1 plus 3 by 2 mu g. Oh wait a minute, there was one t1 over here. I've just forgot that. So let me just put that t1 there. So t1 over there. So mu g t1 plus 3 by 2 mu g t1. So 1 plus 3 by 2 is, come on guys, come on, it is 5 by 2, correct? So this will be 5 by 2 mu g t1 is nothing but v naught. But that's not the end. Just shift the terms. Just shift the terms and you will get t1 is equal to 2v naught. Okay, 2v naught divided by 5 mu g, and that's the final answer. That's the final answer. Understood how to solve this question? This is a brilliant question which involves kinematics, Newton's laws, free body diagram, friction, circular motion, rotation, torque, moment of inertia, rolling, slipping, and common sense. What a problem. Did you guys enjoy this problem? What say, guys? Full package? Very good, very good. What a beautiful looking screen. I love this screen. It's full of equations. I'm loving it. What do you guys say? All right. So my point is, guys, to make you realize that, you know, solving problems is not difficult if you go stepwise. And if you believe in me and if you follow me regularly, trust me, I'm going to make things very easy for you, even complicated situations like this. Don't get scared. It looks, if I showed you this screen before, you would be scared, but the way we approached it looked very simple. So guys, for all the dropper and the 12th standard students, I need to tell you guys that there is a crash course also which is starting, which also has, you know, test series, doubt solving, etc. And it's at a very affordable price. So do not forget to check it out in the link. The offer price is 20% off. Usual price was 10,000. So offer price, because of the 20% off, you're going to get it for 8,000 rupees only. That's a crash course, and it will prepare you till your final JEE Mains examination with mock tests, motivational sessions, etc. So the coupon code for that is SHCC. You can share it with your friends or relatives if they need so, for especially the crash course. And if you want to tell them, hey, you want to study under teachers like Shreyas Sir, then go ahead, do that. And do not forget to join the Telegram link, because that's where you're going to get all the homework. And if you have loved today's discussion, do not forget to subscribe and like. If you're already a member, then no doubt you just have to press the like button, because that's where I'm going to get all the energy and the enthusiasm from. Yes, you can get it, Edge Gaming. Why not? You can. JEE Marmudi, it's in February. I have made a separate video on that. Just check out the video I uploaded on Saturday on the same channel. I have mentioned all the important announcements, very important for the 2021 aspirants. Just check it out. All right. So anyways, guys, bye. Take care. Have a great time. See you tomorrow. And what is tomorrow? Tomorrow, it's all about angular momentum and energy. So do not forget to attend tomorrow's session at 7 p.m. sharp. See you all. Bye. Take care.